Hey everybody, welcome to CPM 3. This is Module 2, Lesson 4. We're going over exponents today, and there are a lot of rules. So, starts off with your definition of an exponent. It's a shorthand notation for repeated factors. So for example, 2 times 2 times 2 times 2 times 2 can be written as 2 to the 5th. The base of the exponential expression is the repeated factor. The exponent is the number of times the base is used as a factor. So, we have some examples right here of what an exponent and a base is. Basically, your base is the big number. Your exponent is the small one. Let's kind of pay attention to what this helpful hint is showing. It says, be careful when identifying the base of an exponential expression. Pay close attention to the use of parentheses. Parentheses make a difference. So, for example, in parentheses, negative 3 squared, the base is negative 3. It includes the negative with it. However, if you have the exact same thing without the parentheses, now your base is just a 3. That exponent only goes to what's directly in front of it unless it tells you with parentheses that it includes more than just in front. But when this one doesn't have parentheses, it does not include that negative. So it's just that 3. So, for example 1, for the following expression, state the exponent shown and its corresponding base. So in A, your exponent is the 5. Your base is the 8. Okay, usually the exponents are pretty easy. On B, your exponent is again the 5. Your base is now the negative 8 because it's included in parentheses. C is where we'll get tripped up. On C, your exponent is still 5, but now your base is only a positive 8. It is only what's directly in front of that exponent. Okay, D and E are similar to B and C. On D, your exponent is 4. Your base is 10x. It's 10x because it has parentheses, so it includes everything in there in parentheses. But on E, my exponent is still 4, but now my base is what's directly in front of that exponent, so your base is just x. Okay, and the difference between these two is on D, when you have 4x in parentheses squared, what that means is that you have 10x times 10x times 10x times 10x. The 10x is what's repeating. That is your repeated factor. But on E, now we just have 10 times x times x times x times x. So there's a difference when you have those parentheses versus when you don't. All right. Example 2, evaluate each expression. On A, 2 cubed means you have 2 times 2 times 2. So 2 times 2 is 4 times 2 is now 8. Now there is a way to put this in your calculator, and it's kind of hard to show you since I don't have a calculator in front of me to show you. But basically in your calculator, you're going to hit 2. You have this little caret key. It looks like an arrow. And 3, that means 2 cubed. So if you put that in your calculator just like that, you're going to use this button here for anything other than a squared. 3 to the first just means you have literally 1 3. So that's it there. Now notice C and D are almost the same. One has parentheses, one doesn't. On this one that has parentheses, this means negative 4 times negative 4. Well, negative times negative makes a positive 16. On D, however, the only thing that's getting squared is this 4. So we've got 4 times 4, which is 16, but then this negative needs to be right here out front. So your answer here is negative 16. And then on E, we're squaring. So that means we've got 1/3 times 1/3, multiply straight across. 1 times 1 is 1. 3 times 3 is 9. All right, so this page here was just to make sure we understand the rules. Let's try this one more time with this. We're going to evaluate. So whatever they tell you x is, just plug it in. So we got 2x cubed, x is 5. So we've got 2 times, you want to put this in parentheses, 5 cubed. When you put 5 cubed in your calculator, you get 125. Use your caret key again, so 5 caret 3. And 2 times 125 is 250. And you could really put all of that in your calculator all at once. B, this is where those parentheses really help and make a difference. We got to put this in parentheses here. So 9, we got 9 over negative 3 squared. So 9 over negative 3 times negative 3 means we get a positive 9 here. 9 divided by 9 is 1. If you don't put this in parentheses and you just put negative 3 squared, then you're going to get a negative 9 right here on the bottom, and you're going to get a negative 1 as your answer, which is not true. It's positive 1. So you've got to make sure those parentheses are there. They make a difference. All right, now to the meat of this. Like I said, the first 3 examples were just making sure we understand exponents. Now we're getting into our rules. We're going to go over 5 or 6 today alone, and then we're going to add on to them next lesson. Your first one here is your product rule. And so you have an example right here, and you have another example right here. I'm going to make my own example so we can go through this and explain it. If I have something like x to the 4th times x cubed. Well, x to the 4th just means I have 4 x's. So that's x times x times x times x. And we're going to multiply that by x cubed, which means I have 3 x's. So x times x times x. So now, how many x's do I have here total? We've got 1, 2, 3, 4, 5, 6, 7 different x's. So this becomes x to the 7th. So how could I have gone from this directly to here without writing this out? You can just add those exponents. And so that's what this rule right here is telling you. If you have a to the m times a to the n, all you have to do is add your exponents. Okay, so let's turn this page and let's try some examples. We've got 4 squared times 4 to the 4th. Since they have the same base, we'll keep that same base, so don't do 4 times 4, you keep the base. And then we'll do 2 plus 5, so I'm going to get 4 to the 7th. Now, anytime you have a number to a number exponent, we need to evaluate that. So in your calculator, do 4 caret 7. And let's see, 4 to the 7th is 16,384. So this is my final answer here. Okay, B is the same thing, but we only have 2 steps on this one. We've got x to the 4th times x to the 6th. Do they have the same exponent? Or sorry, do they have the same base? Yes, the base is both x. So then add these exponents. We'll have x to the 4 plus 6. 4 plus 6 gives me 10. C, you've got y cubed times y. So look at your helpful hint here. It says don't forget that if there's no exponent is written, it is assumed to be a 1. So this is really like y to the 1st. So do they have the same base? Yes, it's both y. So So then add your exponents. 3 plus 1 gives me y to the 4th. Okay, same thing happens here on D when you have multiple bases. It's all has the base of the y. So we've got y to the, then add all 3 of your exponents. So 3 plus 2 plus 7. So we'll have y to the 12th. Okay, and same thing on this one. We've got negative 5 to the 7 plus 8. So we've got negative 5 to the 15th power. This is another one. We got a number and a number. This becomes way too big of an answer. In your calculator, you're going to get negative 3.05 and then times 10 to the 10th power. So they're using scientific notation because that's too big for your calculator. So when that happens, we'll just leave it like this. But on F, we cannot add. Let's say not cannot add. We cannot simplify. Why can't we simplify on this one? Hopefully you said because we have different bases. You have an A base and a B base, so you cannot do 3 plus 3. Those bases have to be the same. Okay, on example 5, we're doing the same thing, but I'm taking all of these a step further. On A, still multiply your numbers together like you normally do. So we're going to do 2 times negative 3, and then we'll add our bases together. So this is, you got an x and an x, so we'll do 7 plus 5. So 2 times negative 3 is negative 6, and then 2 plus 5 is 7. Okay, so notice that when you have numbers like normal, right? Multiply those the way you always would. 2 times negative 3 is negative 6, but then add your exponents how we did from the top. Okay, now this one has multiple bases, but it's still the same thing. Combine your x's together. So I've got x to the 2 plus 3. And then y, remember there's a 1 here, 1 plus 2. So we get x to the 5th, y to the 3rd. Okay, now if you don't need this step right here, you don't need to take it. Okay, I'm doing it so I can kind of show work so you can see where these numbers are coming from, but you don't have to do it. So for example here, think of this as being a negative 1 out front. We've got negative 1 times 3, which is negative 3. Then I have a to the 7th and a to the 1st. So I'm going to get a to the 8th. And then we have b to the 4th and b to the 9th to get b to the 13th. Okay, so these are really easy that you really don't need to show work if you don't need that step. If you need that step, take it. But if you don't, that's okay. You don't need to write those out. Okay, so that was only our first rule. We're going to go through 4 or 5 other ones. So the first one is your product rule. Add those together. Now we're going to use our power rule. Our power rule says, well, here's the power rule. Okay, and just like before, here's an example for you, but let's go through our own example. If I have, if I've got x to the 4th, and this is being squared. That squared means I have this base 2 different times. And you know what? Let's just make that a 3. I've got it 3 different times. So that means I have x to the 4th times x to the 4th times x to the 4th. Well, now this is just my product rule. My product rule says to add these together. So now we've got 4 plus 4 plus 4. So I've got x to the 12th. How could I have gone from my original problem to right here? Just multiply those together. So that's what this is telling me. If I have a to the m all to the nth power, all we are doing here is multiplying our exponents together. So on, this should be a, we have y to the 8th all squared. So we are doing 8 times 2 to get y to the 16th power. Here, 8 to the 4th all to the 5th power. So we are doing 4 times 5. So I get 8 to the 20th power. Now this is another one that usually you have a number to a number exponent. We need to put this in our calculator to get an actual answer. But this is going to be a huge number, so we'll just leave that. Okay, and again, if you don't need this step, I don't care if you don't write it. So for example, z to the 3rd all to the 7th power, we're just multiplying these together. So I have z to the 21st. That's 3 times 7. Okay, so we've gone over 2 rules so far. Pretty easy, right? You're adding exponents, you're multiplying exponents, but you do have to know the difference, and that's when it starts getting a little bit crazy when we go through all of these rules, knowing when to use what rule. So down here on this helpful hint, when I asked this in class, what is the difference? How do I know when I'm using this product rule, and how do I know when I'm using this power rule? A lot of times what people will say is, over here you've got parentheses. When you have parentheses, you're multiplying. Okay, and that is true. When that parenthesis, the reason you have it is because you have a power to a power. So when you have a power to a power, when you have power to power, we're multiplying. But when you have this dot here, when you're actually multiplying your bases, okay, that's when you add. So no parentheses, parentheses. When you have no parentheses, we're adding those exponents. When I have parentheses, I am multiplying. When you have a power to a power. So keep that in mind. Okay, our next rule. So they give you another example right here, but let's do our own example. So if I have something like a squared b all cubed. That cubed means I have this base 3 different times. So that means I've got a squared, actually I'm not even going to put parentheses anymore, a squared times b, a squared times b, and a squared b. Okay, so now multiply. So I've got we've got a squared, a squared, a squared. So 2 plus 2 plus 2 gives me 6. So I've got a to the 6, and then b, b, b. So 1 plus 1 plus 1 gives me b cubed. How could I have gone from here to here? It's not technically distributive property, but you can think of it as that. You're multiplying, you're distributing to everything. So 2 times 3 gives me 6, and if I use that 1 here, 3 times 1 gives me 3. So if you have multiple bases, all to an exponent, you need to distribute that exponent to everything. So on A, we have st all to the 4th. Distribute that 4 to everything. So this becomes s to the 4th, t to the 4th. That's what this rule right here is telling me to do. If I have ab all to the nth power, all they did was distribute that in, and now it's a to the nth, b to the nth. Okay. It's not distributive, so I'm not going to put distributive property, but we're going to think distributive property. So that's all we can do on that one. Those are different bases, so I can't combine. Now on B, biggest mistakes happen when we put numbers in front. You guys will remember to take this 3 and bring it to the A. That also needs to go to the number. So if you have a coefficient, that needs to go to that number as well. So we've got 2 cubed and then now A cubed. Well, 2 cubed, put this in your calculator, but that's just 2 times 2 times 2, which is 8. So my final answer here is 8a to the third. Okay, if you can simplify, you need to simplify. And when you simplify is when you have a number to a number, when you got a number base and a number exponent. Okay, same thing on C. How many things am I distributing that squared to? We've got 1/3 mn cubed. That squared needs to go to 3 different things. It needs to go to my number, my m, and my n. So it goes to the 1/3. So I've got 1/3 squared. Needs to go to that m. So m squared. And it needs to go to that n. So n to what power? Well, now I have a power to a power. When you have a power to a power, we're multiplying. So 2, I'll go ahead and just do this. So we're going 3 times 2. So simplify this. 1/3 squared, we've already did that on that first page. That was 1/3 times 1/3. 1 times 1 is 1. 3 times 3 is 9. So I get 1/9. Can't do anything with that m squared, so it comes down, and then 3 times 2 gives me n to the 6th. Okay, on D, how many things is that squared going to? The squared is going to 4 different terms. To your number, to your x, to your y, to your z. So, 2 to the -5. And when you put this into the -5, this has to go in parentheses. To the x, so we're doing power to power, that means I'm multiplying, so 2 times 2. To the y, so 3 times 2. And then lastly, to the z. So either 1 times 2, but that's just going to be 2, right? There's not an exponent, it needs to go to it. So simplify. -5 in parentheses squared means that this is -5 times -5. Well, negative times negative is positive. So -5 in parentheses squared is 25. 2 times 2 is x to the 4th. Three times 2 is y to the 6th, and then my z squared comes down. And again, if you don't need this step right here, you can go straight from the problem to your answer. Okay, I don't have a problem with that. Just make sure that that coefficient gets squared. Make sure that coefficient gets your exponent, because that's more times than not where we will make mistakes on those. So that was only the power of a product rule. Now I have a product of a quotient rule. Okay, same sort of concept. And let's just use that 1/3. We've done 1/3 in parentheses squared now twice. That means we did 1/3 times 1/3, because my base is repeating 2 times, and that becomes 1/9. Another way we could have done that is by distributing the squared to both things. So now that would have become 1 squared over 3 squared. 1 squared's 1, 3 squared is 9. Okay, so you're almost distributing that exponent to everything on the top and everything on the bottom of your fraction. So there's another example right here of that. And another example right here. But let's go into ours. So we have mn all to the 7th power. So that means that's multiplying towards each other 7 different times. So just distribute that 7 to everything on top and everything on bottom of that fraction. Well, luckily on this one, there's only one thing on top and one thing on bottom. So that means we have m to the 7th over n to the 7th. Okay, same thing on b, but now how many things am I, quote, distributing that exponent 4 to? Well, I need to distribute it to the top x, to the bottom 3, and to the y on the bottom. Don't forget those coefficients. So, on the top here, I have power to a power we're multiplying, so 3 times 4. On the bottom, it needs to go to the 3, so 3 to the 4th, and to the y, so 5 times 4. Again, power to a power. So simplify. 3 times 4 is a 12, so we get x to the 12th. Put this in your calculator. 3 caret 4, we'll get 81. And 4 times 5 gives me y to the 20th. Okay, that's 4 rules. Let's go to the 5th. We have something called a quotient rule. And here's an example of it. Okay, but I'm going to turn the page and do it on this page where we have the actual rule for a quotient. So, for example, if we have something like x to the 7th over x squared, means on the top I have 1, 2, 3, 4, 5, 6, 7 x's. On the bottom, I have 1, 2 x's. When you cancel these out now, think of your fraction rules. 1x on the top and 1x on the bottom cancel each other out. 1x on the top and 1x on the bottom cancel each other out again. So now I am left with 1, 2, 3, 4, 5 different x's on the top. We get x to the 5th. Again, how could I have gone from my problem to my actual answer? Just subtract. So that's what we're saying right here. You have a to the m over a to the n. We are subtracting exponents. Okay, and here's another example of that. So, example 9a, we got 8 or x to the 5th over x squared. So because they have the same base, both have a base of x, we've got x 5 minus 2 to get x cubed. Same thing here. They both have a base of 4. So I've got 4. Subtract your exponents. 7 minus 3 is going to give me 4 to the 4th. This is one that we can evaluate. So do 4 to the 4th. and we should get 256. Okay, same thing on C. We've got -3 as our base, so we'll do 5 minus 2. So I'm going to get -3 cubed. Put this in your calculator, and -3 cubed is a -27. Okay. So I'm going to do a little side note here. Notice how this one's in parentheses. Okay, it's negative because when I have -3 times -3 times -3, negative times negative does give me a +9 here. Bring down your -3, and now we have positive times negative, which is going to give me a -27. So when you have an odd exponent, whether this is in parentheses or not, it's always going to be negative. Okay, on D, we got s squared over t cubed. This is another one. I'll put this in red. That can't be simplified. Why can't it be simplified? Different bases. Okay, if it's got different bases, there's nothing we can do about that. And then lastly on E, we've got 10 over 2. Well, what is 10 divided by 2? That is 5. So treat those numbers just like we always have. So 10 divided by 10 divided by 2 is 5. Then subtract your exponents with the like bases. We've got x to the 5th. We're going to subtract that with 1 because that's x to the 1st power. And then we've got y2 minus 1 because, again, there's a 1 right here. So my final answer is 5y to the 4th. And you can do y to the 1st if you want. That's perfectly acceptable. But it does look a little bit better if we just put y. Okay, but if you put y to the 1st, I will definitely accept that. Okay. All right, we have one more rule that we're going to go over, and it's our zero exponent rule. Zero exponent rule states anything to the 0 power is always 1. And they show you that right here. If they have x cubed over x cubed, if you use this rule right here of subtracting, when you subtract, you get x to the 0 power. But I know if I have the same thing on top as I do on the bottom, that's always going to equal 1. Right? So that's what they're showing you right here. X cubed over x cubed, when you subtract, you get x to the 0. X cubed over x cubed, you got the same thing on top as you do at the bottom, so it equals 1. So therefore, these will always be equal. Okay, so it doesn't matter what you have to the 0 power, it is always 1. Okay, in other words, any base raised to 0 power is 1. Actually. Okay. Now these can get a little tricky. You got to make sure you know what your base is. Keep that in mind. So 3 to the 0th power. It's not 0. It's not 3 because it is to the 0 power. It is 1. Same thing on B. You've got all of this junk right here. 5x squared, y squared. All to the what power? 0 power 1. C, negative 5 in parentheses to the 0 power, it is 1. D, however, is negative 1. Why is that? Because this is not in parentheses, it means that 0 exponent is only going here to the 5. So 5 to the 0 power is 1, but then that negative has got to come down, so you get negative 1. E, you've got some fraction in parentheses to the 0 power. That means 1. F is 4. Okay, why? What is to the 0 power? It is not 4x. It is only x. To make that 0 also go to that 4, it would have to be in parentheses 4x to the 0 power. This does equal 1. But only this x to the 0 power on F is 1. So that means I have 4, bringing down that 4, times 1, x to the 0 power, and 4 times 1 is 4. So pay attention to those bases. It kind of goes back to that first page. If it's in parentheses, it includes everything. If there's not parentheses, that exponent is only to what is directly in front of that number, or that exponent. Okay, so we have gone through 6 different rules now, I think, if I counted those right. So now you have to be able to tell, when are you doing what? When are you distributing the exponent? When are you multiplying? When are you adding? When are you subtracting? Okay, when is it just to the 1 power? So this little concept checked right here says, suppose you are simplifying each expression, tell whether you would add the exponents, subtract the exponents, multiply the exponents, divide the exponents, or the funnest, none of these. Okay, so on A, you have a to the 63 all to the 21st power. I don't care what my final answer is. Am I adding, subtracting, multiplying, dividing, or none of the exponents? Well, this one here is a power to a power. When you have a power to a power, you are going to multiply. Let's just do this right here. Okay, we're just multiplying on A. That looks so sloppy, doesn't it? I'm sorry, guys. Okay, multiply. On B, y to the 15th over y cubed. Well, they have the same base, so we're using our quotient rule. Our quotient rule told us to subtract. Okay, so you're subtracting on B. On C, z to the 16th plus z to the 8th. We did nothing with a plus sign in the middle. Okay, this is just simply combining like terms, and these aren't like terms because you have to the 16th and to the 8th. So this one is a none. And then D, w to the 45 times w to the 9th. This is our product rule. Our product says because these are the same bases, we would add these exponents. So on our last example here of 11, I think this is our last page, right? Yeah. We're just simplifying, and I'm using all of the rules, and we've got to determine which rule am I using and when. So A, x to the 7th times x to the 4th. That's this rule here. This is your product rule. So add. So x to the 7th plus 4 gives me x to the 11th power. B, t over 2 to the 4th, distribute. So this becomes t to the 4th over 2 to the 4th. And now simplify. This gives me t to the 4th all over, put in your calculator, 2 caret 4. And that will give me 16. Okay, C, be careful here. This is when you're distributing, but what am I distributing that squared to, that 2 to two different things we need to do to the 9 and to that 5. So I have 9 squared, and y to the, we're going to do 5 plus 2 or 5 times 2. We need to multiply. Power to a power means I'm going to do 5 times 2. So 9 squared is not 18. Okay, not 9 times 2. What's 9 times 9? Gives me 81. And then 5 times 2 makes that y to the 10th. All right, with this one here, you cannot subtract these exponents, right? The only time we're subtracting is when I am dividing. So therefore, evaluate both of these numbers. 4 squared is 16 minus, what's 4 to the 0 power? That means it's 1. Anything to the 0 power, right, is 1. So then 16 minus 1 is 15. Okay, but you're not doing 2 minus 0 to get 4 squared to get 16. You can't subtract those. The only time you're subtracting is when you're dividing. Okay, E, you've got a power to a power, so we're multiplying. So I'm doing 0 times 3 into 0 times 5. 0 times anything is 0, so it means I got x to the 0 plus 2 to the 0. Anything to the 0 power is what? 1. So it means I have 1 plus 1 to give me 2. F, distribute. How many things am I distributing that squared to? Count them up. Hopefully you said 4 different things. The 3, the y, the 6, and the x. Okay, everything on top, everything on the bottom, please include those numbers. I'm going to change colors on this one because this one's going to take a step or two. So this one means on the top, you've got 3 squared. Here, we've got y 3 times 2. Power to a power, you multiply. Then 2 to everything on the bottom. So 2 to the 6. And 2 to the x. So 5 times 2. Again, power to a power. So let's simplify this. 3 squared is 9. Then we'll have y to the 2 times 3 to get y to the 6th all over. 6 squared, 6 times 6 is 36. And then 5 times 2 makes this x to the 10th power. Now on this one, you've got to simplify. Now, when you're simplifying, the go-to are these bases. I can't simplify those bases because you got one's an x, one's a y. So think on like terms, right? You can't do anything there. But this 9 and this 36, you need to reduce this like you normally would with any type of fraction. So 9 and 36 are both divisible by 9. So I need to divide the top and the bottom. By 9. So 9 divided by 9 is 1. We don't really need that 1 in front of that y to the 6th. So we'll just make that y to the 6th on the top. And then on the bottom, 36 divided by 9 is 4. And then we'll keep that x to the 10th. So make sure you have fully simplified if you can. G, only this top portion is cubed. So I'm going to distribute that cube to everything on the top, but not on the bottom, since the whole fraction is not in parentheses. So we have 2 cubed, a to the 3 times 3, and b to the 4 times 3. So I'm just going to simplify that at first. 2 cubed is 8. We'll have a to the 9th, 3 times 3, and b to the 12th. So now, this is all over -8, a to the 9th, b squared. Okay. So now, divide. I've got -8, or 8 over -8. That's going to give me a -1. My a to the 9th and my other a to the 9th, those are just going to cancel each other out. And then I'm going to subtract 12 minus 2. So this one is -b to the 10th. Okay, that negative came from right here in the blue. 8 divided by -8, positive divided by negative is negative. My a's canceled since you have a to the 9th and a to the 9th. And then I did 12 minus 2 to get b to the 10th. And then my last one here, same concept. This 4 only needs to be distributed to the top. So we've got 3 to the 4th, z to the 8 times 4, power to a power multiplying, and x to the 5 times 4. So simplify that. 3 to the 4th is 81. Then we'll have z to the 32nd, x to the 20th. Okay, so that's the top, and this is still all over -27. Z squared x to the 20th. So, same thing. 81 divided by -27, I think is -3. Yes. Okay, -3. Then z to the 32 and z to the 2nd, subtract those. So I'm going to get z to the 30th. And then likewise on that last problem with our a's, x to the 20th and x to the 20th, those are going to cancel each other out. So my final answer here is negative 3z to the 30th power. We divided here in the blue to get that negative 3, subtracted 32 minus 2 to get z to the 30th, and then my x's cancel out since they're both to the 20th power. Okay guys, that's all I got for this lesson. Rewind this video as you need to. Let me know if you have any questions.